So here we have the function given by 1 minus cosine of x over x squared. We need to find its limiting value when x tends to 0. In the previous question, we used the identity that 1 minus cosine of 2x is equals to 2 sine squared x. So this time we have 1 minus cosine of x, so that will be equals to 2 sine squared x over 2. So let us substitute this value into the numerator of the given function. So we have limit x tending to 0, 2 times sine squared x over 2 divided by x squared. So we have limit x tending to 0. We can bring the 2 to the front of the limit since it's a constant. So we have sine x over 2 whole squared times 1 over x squared. So we have 2 times limit x tending to 0. So we are going to divide sine x over 2 by x over 2 and multiply it by x over 2. So and then we square it times 1 over x squared, which gives us 2 times the limit x tending to 0 sine x over 2 divided by x over 2 times x squared over 4 times 1 over x squared. So we have x squared in the numerator and the denominator, so that will get cancelled out, and 2 times 2 is going to be equals to 4. That leaves us with limit x tending to 0. There's a square here as well. So we have sine x over 2 divided by x over 2 whole squared times half. So by definition, the limiting value of sine x over 2 divided by x over 2 squared will be equals to 1. So we have 1 times half, so our limiting value is half. So I'm using here the definition, the limit x tending to 0 sine x over x is equals to 1. Let us do another problem. So here we have the function 1 minus cosine of 2x divided by x squared. So we're going to change our numerator. So we have 1 minus cosine of 2x, so that will be 2 times sine squared of x divided by x squared. So we have limit x tending to 0. So we can bring the 2 to the front of the limit. So we have sine x over x multiplied to sine x over x. So we can apply the limit to the 2 function. So that gives us 2 times the limit of x tending to 0 sine x over x multiplied to the limit x tending to 0 sine x over x. So by definition, the limiting value of sine x over x when x tends to 0 is 1. So we have 2 multiplied to 1 multiplied to 1, and that gives us the limiting value of 2. Let us do another problem. So here we have the function 1 minus cosine of mx divided by x squared. We have to find out the limiting value when x tends to 0. So we know that 1 minus cosine of 2x is equals to 2 times sine squared x. So that means if we have 1 minus cosine of x, so that will become 2 times the sine squared of x over 2. So this is the formula for half angle. Now if we replace x by mx, so then we have 1 minus cosine of mx will be equals to 2 times sine squared of mx over 2. So let us substitute this value into a function. So we have limit x tending to 0, 2 times sine squared mx over 2 divided by x squared. So we have limit x tending to 0, 2. So we have sine mx over 2, leaving some space here. So this is sine mx over 2 whole squared times 1 over x squared. Now what we're going to do is we will divide sine mx over 2 by mx over 2 and then also multiply by mx over 2 such that we have 2 times the limit of x tending to 0 sine mx over 2 divided by mx over 2. Since we have a square, so I'm going to write it twice. So we have sine mx over 2 divided by mx over 2 times the mx over 2 whole squared will simply becomes m squared x squared over 4, and we have the remaining term, which is 1 over x squared. Now x squared and x squared gets cancelled. 2 times 2 is 4, so we are left with m squared over 2 times the limit of x tending to 0 sine of mx over 2 divided by mx over 2. So we have another sine mx over 2, so we are also going to apply limit to it. So we have limit x tending to 0 sine mx over 2 divided by mx over 2. So that leaves us with m square over 2, because the limiting value of sine mx over 2 divided by sine mx over 2 is going to be equals to 1. So this is the limiting value of the given function when x tends to 0. So here we have in this particular question the function 1 minus cosine of 2x over x, and we have to find the limiting value when x tends to 0. So let us substitute our numerator by limit x tending to 0. So 1 minus cos 2x will be 2 times sine squared x divided by x. So we have 2 times limit x tending to 0 sine x over x times sine of x. So what we can do is we can divide sine of x by x and then multiply with x, such that the limiting value of sine x over x and sine x over x becomes equals to 1, and we are left with 2 times the limit x tending to 0 x, which will be equals to 2 times 0. Therefore we have a limiting value of 0 when x tends to 0. Let us do another problem. So here we have the function 1 minus cosine of 2mx divided by 1 minus cosine of 2nx. So we have to determine the limiting value when x tends to 0. So we can use the identity that 1 minus cosine of 2 times mx is equals to 2 sine squared mx, and 1 minus cosine of 2nx will be equals to 2 sine squared nx. So let us substitute these values into our given function. So we have limit x tending to 0 to sine squared mx divided by 2 sine squared nx. So that gives us, so the 2 and 2 gets cancelled out, so we have limit x tending to 0. Now we're going to do, instead of writing it as sine squared mx, so we're going to write it as sine mx times sine mx divided by sine nx times sine nx. Now we're going to divide the numerator, which is sine mx by m times x, and we are going to multiply mx to it. Similarly for sine mx, we're going to divide and multiply by m times x. We repeat the same thing in the denominator, so we have sine nx over nx times nx multiplied to sine nx divided by nx times nx. So here we cancel out the common factor, which is x squared, and that leaves us with limit x tending to 0 sine mx over mx times limit x tending to 0 sine mx over mx divided by limit x tending to 0 sine nx divided by nx times limit x tending to 0 sine nx over nx, and we have the remaining terms, which is m squared over n squared. Now each of the limiting value will be equals to 1 as per the definition. So we have the limiting value equals to m squared over n squared. So let us do another problem. So here in this question we have the function 1 minus cosine of mx over 1 minus cosine of nx, and we need to determine its limiting value. So we can rewrite our numerator as limit x tending to 0. So 1 minus cosine of mx will be equivalent to 2 times sine squared mx over 2 divided by 2 times sine squared nx over 2, which will be equals to limit x tending to 0. So we have the 2 and 2 gets cancelled out. So we have sine mx by 2 times sine mx by 2. That means we have sine of mx over 2 times sine mx over 2 divided by sine of nx over 2 times sine of nx over 2. Now what we're going to do, we're going to divide with mx over 2 and then multiply it by mx over 2, and here as well we're going to multiply by mx over 2, divide by mx over 2 and then multiply by mx over 2. Similarly in the denominator we divide by nx over 2 and multiply it by nx over 2. So we have this divided by nx over 2 times nx over 2. So we can cancel out the common terms, which is x, from both the numerator and the denominator as well as the 2's. So that leaves us with m squared over n squared times the limit of x tending to 0. So our first limit will be sine mx over 2 divided by mx over 2 times the limit x tending to 0 sine mx over 2 divided by mx over 2 whole divided by limit x tending to 0 sine of nx over 2 divided by nx over 2 times the limit x tending to 0 sine nx over 2 divided by nx over 2. So we finally have m squared over n squared, and all the limiting values will be equals to 1 as per the definition. So this is the final value. So our limit is equals to m squared over n squared when x tends to 0.